All right, ladies and gentlemen, welcome back from your weekend. I hope that everybody's healthy and well, and let's see if we can get this going. So this week, what I'm looking at trying to do, I'm looking at doing cosecant graphs today. I was going to do them both at the same time, but I figured that's too much. So I've got this one example to walk through with you. I got two problems ready to go on formative. Tomorrow we'll do secant. Again, two problems, pretty quick and straightforward. Wednesday, I'm trying to see if I can set up where I can do maybe 4 questions or maybe one of each of the 5 that we've done. And then I'm thinking maybe Thursday. I don't know how I'm going to do this yet, but I'm trying to figure out some sort of a way of doing some sort of a graphing assessment with you guys. Whether it's going to be a timed unit on just when you open it up. I think I can set it where it only will run for an hour and you have to graph 2 questions. I don't know. I'm still working on that, but I'm hoping maybe to do another meeting with you guys on Wednesday the 8th. Probably the same thing, maybe around 11 o'clock or so. Stop, say hi, that kind of stuff, see how things are going, and go from there. So let's talk about cosecant. So first thing we got to remember is cosecant is the reciprocal trig function of sine. So what we're going to do is we're going to graph this just as the same exact way as we were thinking of this as being sine. So we fall back to the same process of, we got to remember that's y equals a sine b x minus h plus k. So we're going to still have the same things. Our period is still going to be a 2 pi over b. So here, again, we got to factor out the 1/2. So we just rewrite, just like we did the past couple of days. We get 3 cosecant 1/2 parentheses theta. Now, from here, remember, if I'm going to divide out by or take out the half, if I'm going to multiply in, excuse me, let's see, we would get, I always do this backwards. So divide by 2, so this would be an 8 pi over 3. Because if I distribute in the 1/2, I'd have 8 over 2, which would give me the 4 over 3. Okay. Minus 2. So we have an a, 3, a b of 1/2, an h of negative 8 pi over 3, and a k of negative 2. So that gives us some funky shift here. So we have our parent and our shift. So it's going to be x minus 8 pi over 3 and y minus 2. So we know we're going to be moving this way. Oops. We're going to move. We know we have to go to the left. So what I'll do is I'm just going to over-exaggerate my graph a little bit more on the left side. Okay. Our b value is 1/2, which means our period, we have 2 pi over 1/2, which means our period is 4 pi. Well, that makes it really, really easy to mark them off. There's 4 pi, 2 pi, pi, and 3 pi. Okay? From here, we know we have an a value of 3, and it's positive. And do that. Same thing is going to apply as we did before. I'm going to originally start this as a sine graph. Okay, so we know that it's got to go at 0 first. It goes to its a value, opposite of a. I'm sorry, back to 0, then opposite of a. I was getting ahead of myself, and then back to 0. So now remember, this is the sine curve. Okay. Now the difference that we have to do here is that we have to graph this as a cosecant curve. All right. Now, before I do the cosecant part of this, I know that I have to take these 5 points and shift them, okay? So first things first, I'm going to take these 5 ordered pairs, because they're going to be my parent function, if you will, and go from there. So we have what? 0, 0, pi, 3, 2 pi, 0, 3 pi, negative 3, and 4 pi, 0. Okay? So for all of these now, I know that these are going to be my ordered pairs as I move them around. So I know I'm at negative 8 pi over 3, negative 2. Pi minus 8 pi. So think of this as 3 pi over 3, subtract 8 pi over 3. I'm going to get negative 5 pi over 3 and 1. 2 is the same thing as 6 over 3. So I get negative 2 pi over 3, negative 2. Sorry, these are bigger than this side here. This is 9 pi over 3. So 9 pi over 3 minus 8 pi over 3 is pi over 3 and negative 5. This becomes 12 pi over 3. Subtract 8 pi, get 4 pi over 3. And I'm back to negative 2. So these are going to be my new ordered pairs. I know that the furthest on the left, let me change colors here. My furthest left ordered pair is going to be negative 8 pi over 3. Okay? I know that this value is going to be at negative 2. Excuse me. The next one is at negative 5 pi over 3. Well, actually, before I get that far, now I know my furthest right is 4 pi over 3. 4 pi over 3 is a little bit more, think of it as it's a third of the way between here and here. So I'll say it's about here. I'm just doing it this way just to try to space it out to get a good idea of what it's going to look like. And then it's going to end back to here. So think of it this way. These 2 points, the start and the end, these two guys are on the same horizontal line. Okay? Just like they were up here. They were on the same horizontal line here and here. We've taken these and just moved them down. All right. So I know that the halfway has to be at negative 5 pi over 3. So we'll call this, I'm just kind of guessing about here on my line. About here, we'll call that negative 5 pi. I'm sorry, that's negative 2 pi over 3, excuse me. Okay, that's my halfway spot. So to the left of that's got to be the negative 5 pi over 3. And to the right of that's got to be by pi over 3. Now, obviously, I think my spacing got a little bit bad in here, but, you know. At least I have this positive and this is negative, so we're above the curve here for that. Now, we have negative 2 and negative 5 pi over 3 are at positive 1. And then I go back down to negative 2. And then at pi over 3, it's at negative 5. So here's 3, 4, 5. Now this is my kind of badly drawn sine graph. Okay. Now remember, if you go back to the original, this was 0, 0, and 0. Same idea is happening here. We have, this is a 0, this is a 0, and this is a 0. Since cosecant is the reciprocal of sine, if this is 0 for sine, that means it's an asymptote for cosecant. This is a 0 for sine, which means it's an asymptote for cosecant. This is another 0 for sine, which means it is an asymptote for cosecant. Think of this as the 1. Somewhere between here and here is halfway, which means it has to blow up and blow up. So what happens here for cosecant graphs, you plot, once you get your 3 that are on the same horizontal line, those 3 dots, those 3 points become asymptotes. The other point then, the peak or the dip, they blow up the other direction. So these ordered pairs technically are for the sine shift. What we do then is we graph the sine just like we did normally, and then the only last little bit that you have to do is remember that you're working with cosecant. You just draw in your asymptotes at the 3 spots that are on the same horizontal line, and then you just blow up the other direction. And that's really all there is to it. I'm going to try and give you guys, like I said, I have 2 questions on the formative site right now, and hopefully you'll be able to work through those with this. Okay? Good luck. and we'll do a secant one tomorrow. Thanks, guys. Wash your hands.